Any suggestions? Any suggestions? Share with us, please, if you have suggestions. Let's hear them. Is it a difficult one? So we have vector A plus, this is adding vector B. What we are told that is the result is 6i plus j. So that result there is 6i plus j. And if we subtract, if b is subtracted from a, that means it's a minus vector b. The result is minus 4i plus 7j. So the question is, what is vector a? So in this case, if you look at the two, if we add the two vectors, the two vector sums, so let's say this gives us vector c, the resultant, and this gives us vector d. So meaning if we add vector c and d, c plus d like this, that means we've got a plus b added to a minus b. So what that means is vector b minus vector b will cancel out because they're in opposite directions, and that leaves us with 2a, a magnitude of 2 times the vector a. So that means if we take half of the sum of c plus d, half of c plus d, that should give us vector a. Half of c plus d gives us vector a. But now what is c? According to what we have, this is c. So this is vector c and this is vector d. So that means it's half of 6i plus j added to vector d, which is minus 4i plus 7j. This should give us vector a. So adding 6 minus 4i, that gives us 2i plus j plus 7j, 8j. That's the sum. And half of that is equivalent to a. That means taking the half inside, we've got I plus 4j equals to a. So this is the vector a as requested by the question. Then the question says, what is the magnitude now of this vector? So the magnitude of this vector is a magnitude equals to root of 1 squared plus 4 squared. And that's root of 5. That will be not the root of 17, actually, sorry. Why did I say 5? So it's 1 plus 16, the root of 17. So can you calculate and give us the square root of 17 so that we know what that answer is? What is the square root of 17? Anyone got that one? So according to my calculator, this is 4.12. Okay, yes, very good. So we have 4.12 there. Someone just typed 4.12. That's correct. So this 4.12 is one of our answers here. Which is B. So B should be our choice. 4.1 is the correct answer. Okay, so that's basically how you find the magnitude. You have to find this vector A first and then get the magnitude of that vector. So that's the process. If you have any questions, please feel free to just highlight, and we'll try and address them as quick as we can. Okay, so that's number 10. Number 11 is quite an easy one. Number 11 uses the same notation. So in this case, we've got vector A being equal to 12i minus 16j, and vector B has got a component of minus 24 in the x and 10 in the y. So what is the magnitude of the vector C, which is equal to 2a minus b? So first we have to express 2 times a, subtract b from it, that's our vector C, and get the magnitude. So that's the vector C is equal to 2 vector A minus vector B. So 2 vector A is actually 12 and 6 and minus 6 actually. Then vector B is minus 24 and 10. So I've just put the x component at top, the y component at the bottom, or the I at the top, the j at the bottom. So that gives me such a matrix. Multiplying by 2, we get 24 and minus 12. And this is subtracted with minus 24 and 10. So 24 minus 24 should give us 48. Minus 12, minus 10, minus 32. That's our vector C in that notation. So this is 48i minus 32j. But what we want is the magnitude of C again. And that magnitude is the root of 48 squared plus minus 32 all squared. And taking that magnitude would give you what? What would what would be the magnitude of that expression? Okay. Anyone got that one? $57.6. Did I see a 57.6 somewhere? Did you also get the same? So I'm getting 57.6, which is none of these two. Or did we lose it somewhere? So it's 2a minus b, and given that vector a is 12 and minus 16. Oh my god. So it's 12 and minus 16 instead of minus 6. Sorry about this. Should have corrected me, guys. Are you not following? So 2a minus b, a is 12i minus 16j. So this should be minus 16, which makes it negative 32 after multiplying by 2, and negative 42 after the subtracting negative 10. So going back to the calculator, that means we have a 42 there. and 63.7. So this is 64 to the nearest whole number, or to two significant figures. That will be 64. Let's check. So the magnitude of vector C, which is 2a minus b, should be 64. That's 64. So that's quite simple with vectors. You just have to be careful to make sure your components are copied correctly. Avoid the error that I just did in this question. And question number 12 has got vectors again. If vector A is given by the notation 15 for magnitude and 80 for the angle, so that means this will be 15 cos 80 in the I plus 15 sine 80 in the j. The notation is still the same as shown there. And vector B is 12i minus 16j. What is the magnitude of A minus B? So we've got vector A being equal to 15 cos 80 I plus 15 sine 80 j. And vector B is 12i minus 16j. So A minus B, vector A minus vector B will be equal to 15 cos 80 minus 12i plus 15 sine 80 minus 16 for the j. And we want the magnitude again, so we have to do the modulus. So just do the quick calculation of the parts in brackets. 15 cos 80 gives us 2.604, and from it we subtract minus 12. We have minus 9.395 I. Then 15 sine 80 is plus 16, which is 14 plus 16 plus 30.77 in the j. So these are the components of the sum or the difference between vector A and vector B, A minus B. And the magnitude of that will be the square root of 9.395 squared plus 30.77 squared. And this is giving 32.17. This is the magnitude of vector A minus B. Are we following, guys? Are we following? 32.17, the magnitude is still 32 there, and that should be okay. Okay, I'm not gonna do question number 13. I'll leave this one for you. Can we work out question number 13? Let's work out question number 13. You can type your answer on the chat section, or otherwise just unmute your mic and tell us what you get. Can you do that in the next 2 minutes or so? Then we'll check what we will have got after then. So you have vector A given by a magnitude of 10 at an angle of 30 degrees, and vector D has a magnitude of 25 meters at an angle of 130 degrees. What is the magnitude of the sum of these vectors? So that's another simple one. That's another simple one. What have you got? Tell us what you've got so that we can continue. Can you please repeat this example? Which example is that you're asking about, Zwelihle? Is it the one before question 13? Is it question 12? Are you asking about question 12? Are you asking about this one? The last one. Okay, so question 12. So remember from question 12, we've got saying A minus B, which is this one. So we've got vectors A and B. Vector A is given by that notation, which we are told that for a notation that is given as A theta here, this notation means the magnitude of the vector is A and the angle for that vector is theta, such that it has components in the x and in the y. So the components are such that the x component is A cos theta, the y component is A sin theta, right? So that's why that notation is given there. So A is given now as the magnitude A is 15, the angle theta is 80, meaning the x component is 15 cos 80 for the x component. Of that vector. And the y component of that same vector is 15 sine 80. That's why it's in the J, right? So according to the given notation there. So now we need to subtract the two vectors. The second vector is vector B, which is 12 in the x and minus 16 in the y. Now when we subtract the two, we take the x components together. X component for vector A minus x component for vector B, which is 15 cos 80 minus 12 in the I. And for the y components, we do the same. 15 sine 80 minus the minus 16, which is the y component in the B. So it's A x minus B x and A y minus B y. So the x components together, the y components together. So when we do that, evaluating your cos 80 gives you got 26.93. Where did you have it different from what I have here? Sorry, this is, I hope. Lozi, is that for question 13? I hope that's for question 13, right? We'll check. We'll check. So I was still going through question 12 again, which Zwelihle had asked us to look at again. So once you add the components from or the terms from the same component or subtract them, then you take the magnitude. So after taking 15 cos 80 minus 12, we got this 9.35i plus 30.77j. Then you take the magnitude by squaring, adding the squares. So it's minus 9.395 squared, which gives you a positive of still, plus 30.77 squared. And once you add the squares, you take the root, that should give you 32.17. I hope that's clear now, Zwelihle. Hope that's clear now. Okay, if you still don't understand anything, you just tell us where you are missing it, then we'll try and see how we can help you. So now the question that we have as question 13, Lois says, I get 25.26 for 13. Okay, good. So we've got 25.26, we've got 26.93. This is getting interesting. The difference there is, yeah, it's not really big close, but I don't know why we have a difference. But that's too much for a rounding error there. But anyway, let's look at it together. Let's look at it together. Okay, question 13, I'd written it there. We've got vector A Someone got 34. Wow. Who is this one? Ethan. Okay. Thank you for those answers. So now we have A, B, C. A 26.93, B 25.26, and C is 34.56. So that actually shows you if we give you multiple choice, you can still choose different, take different choices for your answers. But anyway, let's verify which one is the correct one. We are given vector A, we are given vector D. What is the magnitude of the sum of these two, which is a simple one? So notation A is 10 cos. So remember, you should not confuse cos and sine. The x component is cos, 10 cos 30, right? I plus 10 sine 30 in the J. That's for vector A. And vector D, it's not B, but D, is 25 cos 130. Remember, this angle also means something there in the I. It's already in the second quadrant, if you want to look at it that way. Plus 25 sine 130 in the J. Now the sum of the two, A plus D, I can even do this and just add. So this is A plus D equals to 10 cos 30 adds. So the operation is adding this to that, this to that, and this to that. So 10 cos 30 plus 25 cos 130 should give us, let's see, I'll just evaluate 10 cos 30 separately. 10 cos 30 gives us 8.660 plus 25 cos 130, so that you'll be able to follow, gives us minus 16.069. 16.0 it's actually 0696, which is 070. Okay, then plus 10 sine 30. So 10 sine 30 should be 5, I hope. Yes, it is. So that's 5. So this is for the I. All this is for the I. Then plus, and what's that? Gives you 7.41 I. Okay, someone has just evaluated that one. I think 7.41 I, yes. And 24.15 J. Interesting. So the 25 sine, let's check that. I think you're right. 25 sine 130. 5 plus 19.15 in the J, which is 24. Good. 24.15 J. Thank you. I'm also getting 25.26. Okay. Minus 7.4. Yes. Minus 7.4. Thank you for that. You corrected yourself. Well done. Okay. So we're looking for the magnitude of this vector. That is these values. So let's see. I'll just calculate on the calculator that you guys can see, so that clear everything. Is the square root of, open bracket, what is squared minus 7.41, negative 7.41, close bracket, and square that, added to, open bracket, 24.15 squared, 24.15, close bracket, and square. 25.26. We had 25.26. 25.26 meters is the magnitude of A plus D. That's 25.26 meters. So let's see. 25.2. Alizwa, well done, Alizwa. At least I got 25.26. Ethan, is that, was that you? Okay, so Ethan had to correct to 25.26. Well done again. Then I'm sure Roshan, you should have got, I get 25.26 again for 13. That's good. So Lozi, check why you got 26.93. I'm sure you just missed it somewhere, but you should have been in the right direction. But anyway, that's the way in which you work this out, given the notation like that. It's a thing of you getting used to the notation and knowing what it means. What this notation means is if you have a vector and its magnitude is A, right? And the angle is theta like that. Remember, the magnitude is a result of adding your x component, ax, right? And ay. So which means if you add vector ax, you go this direction. Then you add ay, you go that direction. Their sum is equal to the resultant vector whose magnitude we refer to as a. So a theta, this ax is equal to a cos theta, and it's in the I direction. This ay is equal to a sine theta, and it's in the j direction. That's basically what that notation means in terms of adding those two components. Okay. So thank you for your contributions. We appreciate that, and yeah, you did well with that. So next question is question 14, which is quite simple. The same thing about the notation is given in the instructions, but the diagram below shows a path taken by a sailboat tacking sideways because it cannot sail directly into the wind. So the exhibit or the diagram to answer the following questions, you use this diagram to answer the following questions. So we have the boat moving from O to B. That is in the direction, I think that's north east. Yeah, northeast at an angle though. Then from B to C, that would be southeast. Then from C to D, northeast, and then southeast. And at the end of the day, we find it at point E. The total refer to the exhibit in 3.4, which is this diagram. Find the total displacement of the sailboat, the vector sum of its displacements OB, BC, CD, and DE. So we want OE. What is OE? What is OE? What is OE? You can just look at that diagram and give the answer. It's possible. OE isn't a difficult thing to find there. The writing is on the wall. 6298 East. Perfect. It's 6298 East. You don't need to work this one out, right? That's correct. Thank you, Rashan and Cindy. So it's 6298 East. There's no working out of anything here because the displacement is just the straight line connecting O and E, and that distance there is 6298, and this direction is to the east. That's the vector. So the vector sum of all those displacements adds up to the displacement OE, which is 6298 east. So it's like just moving straight from O to E, that distance. So that straight line joining the 2 points O and E is the displacement, and it means it's a distance with a direction towards east. So that's C. That's C, that's C, that's C. Oh, we didn't check this one, did we? What did you give us for this one? 25.2, which is 25. Or just, I think it's correct though. I forgot to check. Okay, fine, happy. Then this one, 6298 East. And Okay, good. So question 15. Question 15 says, what is the direction of the sum of these two vectors A and D, where A is a magnitude of 10 meters at 30 degrees and D has a magnitude of 25 meters at 130 degrees. So it's almost the same question, similar to the questions that we've been looking at. So can you give us the direction of the sum of these two? So this one is not magnitude. Take note, the question says what is the direction. So we want the direction of the sum of these two vectors. What is that direction? 107 degrees due to it being in the second quadrant. Wow. How did you get that? That's a good one. How did you get that? That's very correct. It's 107 degrees. But how did you get 107 degrees? Use the resultant equation and calculate theta. Okay. So the resultant equation, what was your resultant equation? A plus D equals to 10 sine 30 plus 25 sine 130. As I is negative, it must be in the second quadrant. Yes, it's true. So your I component is negative. Okay, that takes it to the second quadrant. Okay, that's fine. That's correct. And what was your value for theta? So this is the I plus 10 cos 107. Okay. 10 cos 30. That's correct. That's fine. So with 10 cos 30, so when you got 107, did you use cos or sine, or did you use, which formula did you use? That was my question. Which formula did you use to get to 107? Because here we have got sine 30, we have sine 130, cos 30, and 25 plus 25 cos 130. So my question was, which formula did you then use to express for your theta, which is 107 for the resultant? I use arctan y over x, got 70. Very good. That's where we wanted to get to. That's good. That's good. So express 10 sine 30. We said this will be 5, I think. So that's 5 plus 25 sine 130. That did you say, did I miss something here? 25 sine. So which one was your negative? Your x, did you say your x was negative? Oh, it should be cos. Yeah. Yes. X was negative. Yes, you're right. So please take note, cos there for I, it's always cos. Okay, it's usually cos. Sine there and sine there. Sorry about that. So 10 cos 30 first, 10 cos 30 and 25 cos 130 minus 7.4 I. Then the other one is where we have the sine. 24.15 plus 24.15. So this is similar to the magnitude we worked earlier. If you remember, we had these two for the x and y. But now this is the magnitude of vector. We can call this vector f, the sum of a and d. But then the angle, for your angle, phi will be arctan. So remember, if it's minus 7.4 I, if you put it on a Cartesian, you have your vector, the minus 7.4 in that direction, minus 7.41, and the 24.15 going in the y direction as 24.15 up there. So now the resultant, you can get your resultant by doing that. Then your resultant is that angle there. Okay, an ugly line, but it's okay. So this is our resultant, F. And F is at an angle. Remember our angle, when we deal with angles, we start from 0 degrees there, and we want that angle is what defines our phi, right? So what we are finding first here is, let me call this angle alpha, like that. So when we say arctan alpha, tan is opposite, this is the opposite, over adjacent, which is this one. So arctan y over x, that's what who's this Russian says used arctan y over x. So by doing arctan y over x, you are finding this angle alpha instead. So it's alpha equals arctan y over x, which is arctan of minus 7 of 24.15 over the x is minus 7.41, which is what, because it's negative, it's in the second quadrant, you're right. So the arctan of that 24.15 divided by negative gives you negative 72.94 degrees for your alpha. So this angle is negative 72.94 degrees from a 180 degrees. So if you say 180 for your, what did you call that, phi? The angle phi there is 180 minus 72.94. This is where you get the 107 degrees. That's perfect. That's perfect. So well done. You did that one in a short space of time. I'm sure everyone else can follow. 107 degrees is C of our choices. So that's basically the correct answer. Okay, so I hope you were able to follow. If there was anything anyone didn't understand, feel free to ask before we move on to the next thing. Do we have any questions? So if there are no questions, I'll just move to the next set of questions from motion in one direction. We'll start again with question number 10. Yeah. Okay. There is our question. Okay, so this is TUT2, question 10. And it reads, an automobile manufacturer claims that its product will, starting from rest, travel 0.4 kilometers in 9 seconds. What is the magnitude of the constant acceleration required to do this? Knowing your equations of motion will help you in this case. So what are we given? So with these questions, what is important is to first do a collection of the information that is given in the question. So if you use for your displacement or distance moved S, in this case S is 0.4 kilometers. or that is 400 meters. So the SI in SI units. Then we are given the time in which the acceleration occurs, and this case is 9 seconds. What else? What other information are we given from this question? There is some hidden information there. What is it? What information is given but hidden? So already A is an unknown which we need to find. Starts from rest, yes. So the term that says it starts from rest is very important. That term is very important. And what does it mean? Vi is 0. Our initial velocity Vi is equal to 0. Obviously, the units are meters per second. Okay, so if we have all this information, how do we find A? How do we find A? We only have time, initial velocity, and displacement. So how do we find A? Suggestions? So we need to find acceleration given time, displacement, and initial velocity. So we don't have final velocity. So you only have, is it two equations? Okay, yeah, so there are mainly two equations that have A in them. The simplest one being acceleration is equal to final velocity minus initial velocity over change in time, right? And in this case, we don't have the final velocity. We don't have that. So this is out. What is the other expression? The other equation that can give us A. It is in terms of the displacement S, which is initial velocity times time. Or you can put delta T there, plus half the acceleration times that time squared. So this one will be a good one because we have our initial, which is 0 in this case. So that goes out. We have displacement, we have time. So our displacement, which is 400, is equal to half A, which we want to find, times T squared, which is, what was T, 9 seconds, times 9.0 squared. So making A the subject, it means we multiply by 2 and divide by 9.0 squared, both sides. So this cancels that, this cancels that, and we remain with A equals to 800 over 81 over 9 squared. That should give us our acceleration. And what is that? What is the magnitude of this constant acceleration? This gives me 9.9 meters per second squared as the acceleration. I hope you got the same. But so it's a matter of you knowing your given information and what is the best equation to use which doesn't get you stuck. So the equation should be one in which all the quantities are given except the one being sought for. So in this case, we're looking for A. The rest of the quantities are known. And hence we resorted for this type of equation to find A. So for the solution, for that solution, 9.9 is there, so it's already shown. So that's the acceleration that you can get for this question. Okay, question number 11. For question 11, a particle starts from rest at x initial equals to 0 and moves for 10 seconds with an acceleration of 2 centimeters per square second. For the next 20 seconds, the acceleration of the particle is let's see what is hidden there. So the acceleration of the particle is -1 centimeters per square second. And what is the position of the particle at the end of this motion? What is the position of the particle at the end of this motion? Okay, so I'm gonna leave this one for you to see if you guys have picked something from your lectures in class on this subject. So what did we say is the first thing to do? Can someone guide me? How would you answer this question? What would be the first thing? Please feel free to unmute your mic. Let's chat. Let's talk. Let's talk. What info have we been given? Yes. So what is the info given? So this is question 11. Info, data or given quantities. What data do we have? What is the given info? Let's put the info together and see. What is the info from the question? Let's list it. Let's list it. What's the first thing there? VI is 0. Good. Initial velocity is 0. And acceleration values, two acceleration values and times of acceleration. Okay. So there is an initial moves for 10 seconds. So t for the first part of the motion is equal to 10 seconds with an acceleration, I'll call that one for the first part of the motion, of 2 centimeters per second squared for the particle. Okay. Then for the next 20 seconds, then so delta t1, first 10 seconds, next 20 seconds, 20 seconds, that is the 2 times that Roshan said we are given. The acceleration in that second part of the motion is minus 1.0 centimeters per second squared. Okay, so important to note is we're starting from rest. That's number 1. 2, we have 2 parts of motion, 2 different parts of this motion, where the first part we move for 10 seconds with an acceleration of 2. The next part of the motion, so this is the A part, or number 1 part, because we said T1 and A1. The B part, we are gonna move for 20 seconds with an acceleration of -1 centimeter per second squared, which is basically a deceleration. So otherwise, we need to find the displacement in both case 1 and case 2. So we've got our S1, which is unknown, and S2, which is also unknown. So this should give us the position of the particle after from xi. So initially xi is 0, x initial, the point there is 0 meters, the starting point. So the final point will be S1 plus S2 away from xi, from 0. So now how do we find S1 and how do we find S2? How do we find S1? How do we find S2? So we're given initial velocity, we're given acceleration, we're given time. Yes. That should make it easy for us to find S1. How do we find the displacement S1, or the position after 10 seconds? So it's not very different from what we did in the previous question. So you can pick it up from there. Okay, good. S1 is 100 centimeters. 1 meter. Okay. S1 is 100 centimeters or 1 meter. How did you get that? Roshan, you got 1 meter. How did you get this 1 meter?
So I use the equation from question 10, the same equation of motion.
Okay, so that is V1 times the time plus half a t, the time is t1 squared. Okay, good, that's correct. Since initial is 0, we don't have that term. So our displacement is simply half of 2 centimeters times 10 squared. So half of 2 is 1, 10 squared is 100. Very good, 100 centimeters. That's correct. We're done with that first part. So we have 1 meter of displacement in the first part of the motion. Now, how do we find S2? Is it wrong to leave the answer in? No, it's correct. So you have to be consistent. Once you deal with centimeters, make sure you have centimeters everywhere. So remember, our acceleration was given in centimeters. So you have to make sure everything else that has to do with distance is in centimeters. That is where your correctness or your wrongness can be determined from. So if you had a velocity there and that velocity was in meters per second, then you would rather convert it to centimeters per second so that everything is consistent in terms of the units. You can't use meters per second there and add it to something that is in centimeters per second. Otherwise, convert the acceleration again to meters per second squared. What we want is consistency so that you add units that have the same meaning or same sense. Okay, so it's not wrong as long as you are consistent with your units. If you use centimeters, make sure it's centimeters throughout. Okay, good question. Thank you, Lazi. So now the part 2 of the motion, part B of the motion, where our time is 20 seconds, our acceleration is minus 1 centimeter per second squared. The question now is, if we are to use the same, or can we use this same equation? Can we use this same formula? Or we have another one? So either way, I think we need to use the same formula. But if we are to use the same formula, then what does that mean? We need to find the initial velocity as we go into the next part of the motion. So that means having an acceleration, an initial velocity and time, our final velocity Vf is equal to V initial plus A t. So we can find V final after 10 seconds, which is 0 plus the acceleration of 2 centimeters per second squared times the time, which is 10. So this gives us a velocity of 20 centimeters per second. 20 centimeters per second as our V final. So with that V final, after 10 seconds, which means that becomes the V initial going into the next part of the motion. So the V final for 1 is equal to V initial for motion 2, which is 20 centimeters per second. So now let's calculate. We now have all the required information. Can we calculate? Can we calculate that? So V initial for motion 2 times T2 plus half A2 T2 squared. What do we get? What do we get? What do we get? Do the math. Hello, are you still there? Are we still there? Are we still there? Alive and kicking? Okay, so that's 390 centimeters. Okay, close, but not quite. How did you get 390? What happened? How did you get 390?
So I
Hmm?
calculated the final velocity at in the first section of the equation of the question, and then I put that into the original formula with displacement equals vi times time plus half acceleration t squared, and then I got 390 centimeters.
Did you use the negative for the acceleration?
Yeah, I did. Yeah,
You did. Okay, let's confirm that. So Lozi got
but I
200
don't.
centimeters. And now, remember our initial velocity there is 20. So we have 20 there, multiplied by, that's for S2, multiplied by T2, which is also 20 seconds. So 20 centimeters per second times 20 seconds, it gives us 400 centimeters. Then plus half of minus 1 multiplied by 20 squared, because the time in motion 2 or motion B is 20. So 20
Oh yeah,
squared.
I forgot the squared.
You
Lol, I
forgot the
forgot the
square.
squared.
Yes, yes. Yeah. So at least you saw where you had made the mistake. So now we have 400 minus 200, and this should give us 200. Okay, that's why you're 390. That's good. So it's actually 200, which is correct according to Loazi. Now, if we have 200 as our S2, what is the new position of the particle? What is the new position of the particle? What is the new position of the particle? Remember, the particle moves, yes, 3 meters, simple. So it's 3 meters. The particle moves 1 meter first and then decelerates over 2 meters, and the total displacement from x equals to 0 is x final is equal to s x0 x initial plus s1 plus s2. So since x initial is 0, our reference, s1 is 100 centimeters, s2 is 200 centimeters. You add those two, you get 3 meters. So our x final is 3 meters away from the initial position. As simple as that. As simple as that. So So take note with these questions, the sign is very important. The signs are very important because they say something about direction. They affect the way in which you get your final answer. So you should be very careful. If you have a negative acceleration, use it as given. So that's also another thing. And also take note to avoid these small calculation errors in truncating from your formula into your calculation. So the things like squaring where you need to square, or subtracting where you need to subtract instead of adding. Those are very important things to try and avoid. Okay, question number 12. A stone is thrown from the top of a building um, with a vertical, with an initial velocity. So it's it's thrown. So remember, thrown and released are two different things, right? If something, what is the difference if we would use thrown and we use a stone is released from the top of the building? What will be the difference between those two statements? Are they the same? Initial velocity will be different. Yes. So if it is thrown, initial velocity is non-zero. If it is released, it's starting from 0 and increasing as it falls under gravity. So for something thrown, its initial or launch velocity or takeoff velocity is not 0, right? So this stone is thrown from the top of a building with an initial velocity of 20 meters per second downward. Okay, so we have an initial velocity given there, and the top of the building is 60 meters above the ground. How much time elapses between the instant of release and the instant of impact with the ground? So with some of these questions, I just like at least to have a picture. So we have our ground, we have the stone thrown, and this is 20 meters per second downward, right? And the height of this whole setup is 60 meters. Okay, now the data: V initial 20 meters per second. What else are we given? What else are we given? So the issue with signs now, it's up to you. Remember, the signs are up to you. If you want to take the downward direction positive, you're allowed. It's not like it's always like downward negative. So in my case, I'm going to choose downward positive. It makes it simple because even my displacement 60 meters downward becomes positive. I don't get to be confused about this was upward and opposing the downward direction and start doing all these things with the negative sign. Whatever you choose, if you choose your negative to be positive, sorry, negative to be upward, then that's it. Everything going up is negative. If you choose your negative to be downward, everything going down should be negative. You should be consistent and keep it that way. So now I've chosen the positive to be the downward direction. So I'm going to use positive 20 meters per second for VI as it goes down. So if ever I get anything that's positive, I know it's in the downward direction. That's the trick. Okay, so we have displacement here. Displacement is 60 meters and it's still downwards. It's positive, it's a displacement. So without the negative, it means it's also in the same sense as the velocity. Then we need to find time, but we have another quantity in this question that is hidden and not given. Which quantity is that? G. Okay, good. So that quantity is G. Yes, it's our acceleration. Our acceleration is equal to G. And is it positive or negative? So 9.8 meters per second squared. You have given it. Are we going to use it with a positive sign or negative sign? Are we going to use it as you have given it to us? Positive 9.8 meters. Good. That's good. Meters per second squared. It's positive because it is in the same sense as the velocity and displacement that we have said are positive. So we've taken our downward direction positive, acceleration is also positive. So now with these three quantities, can we find, yes, people are alive. Thank you. That's Anati also contributed. That's appreciated. So we have positive G, or positive 9.8 meters per second squared. And now with those three quantities, we need to find the time between launch and impact. How much time does it take to reach the ground? So give us the formula. Which formula is in terms of time that we can use here? So there are lots of formulas. So we've used some of them up there. We've used some of them up there. Which one is it? There's this one. So we just don't know the final velocity, of course. And we don't know the time, so we can't use this. Maybe this one, the second one, the one that we use from the beginning. A is V final minus V initial over time. That was still a result of that one. But this one in terms of S might be your best shot. But yeah, you tell us. What do you think? Or should we list more formulas? Which formula is still missing here? S is equal to v final squared minus v initial squared over 2a, or v final squared equals to v initial squared plus 2as, which is a consequence of that equation. So we have had our first equation, second equation, and this is our third equation. So v squared equals to u squared plus 2gs to find v, then v will be u plus gt. We then find, okay, to find the time. Okay, that's one way. I like that. Can you go ahead and use that formula? Go ahead and use that formula. Let's see if we get the same thing. So I'm gonna resort to using the one that we've been using all along. I know you don't like using the quadratic formula, so you try by all means to avoid s equals to u t, what is v1t plus half a t squared. But use that method. It's a good method. It should give us the same solution at the end of the day. So let's see if we get the same answer. Then I would know there are many ways of dealing with a cat. Okay, so in this case, I've got 60 for my s. My vi is 20. My t is something I need to find. Then plus, yes.
Yes.
Someone just
Muted their mic. I'm getting feedback.
Okay. So we have 9.8 there, and then we have t squared. So I have a quadratic equation. I don't mind dealing with quadratic equations. But anyway, let's see what we get. So that means we've got 4.905 t squared, 905 t squared, plus 20 t minus 60 equals to 0. This is our quadratic. And that means t, from your quadratic formula, what does the quadratic formula say? Quadratic formula, x equals to minus, I'm forgetting that formula. Is it minus b plus or minus the square root of b squared minus 4ac, everything over 2a. I hope I got it right. I just have to confirm. Let me just check it somewhere. Anyway, usually you'll be given, what do you call this? You'll be given these formulas and constants. So minus b plus or minus the root of, okay, so I'm still in good shape with that formula. So this is basically a result of, if you have an equation that has got, what is it called? A x squared plus bx plus c equals to 0. So your coefficient of x squared is your a, coefficient of x is your b, then the one that has a constant without the x is your c, and then you can plug in to get the value of the unknown x from those coefficients. So this is what I'm gonna do, equals to minus b. So this is our a. I'm just gonna do this. This is our a, our b, and our c, which is negative. So minus b is minus 20 plus or minus the root of 20 squared plus 4 times a, 4.905, times c, negative 60. Everything divided by 2 times 4.905. I get my possible solutions for t. So the beauty of it, I can plug it into the expression, the calculator as is, and the calculator does the rest. So let's see how easy that is. We have minus b, which is minus 20. I'll start with plus the square root of b squared, which is 20 squared, 20 squared minus, open another bracket, 4 times a, 4.905. Someone got t is 2 seconds. That was quick. 4.905, okay. 4a times minus 60 times negative 60 close bracket. Okay, that's that bracket and that bracket, 19 point. Okay, so it's supposed to be everything over. Open that and go to the other side. Everything is divided by 9.8. 4.905, okay, 4.991 basically, 4.91 is 9.8. Okay, 2.011. Okay, there's my 2 seconds as well. I also got 2 seconds. So the other solution there is when we have a negative sign there and it's -6, and you know we can't have negative time, so that solution is discarded. We can discard that solution. So we have 2 seconds. So the quadratic formula is also giving us 2 seconds, which is like the A that's already showing. So who was this who got that answer quickly? That was Roshan. Okay. So Anati, hope you used, did you use your formula? Roshan, which formula did you use? Which formula did you use?
So I used the one that you mentioned earlier where it says displacement equals to VF squared minus VI squared over 2A. Then I solved for VF, right? And then I got that value. Then I plugged it into the basic formula VF equals VI plus A times T.
Okay.
And I solved for T.
That sounds okay. That sounds simple as well. So as long as you know where you're heading and what you're doing, you okay. So yes, Anat also used the same formula as Roshan did, and the answer is the same. Okay, all right. V squared equals to U squared. That's Tenyane. All right, Anati. Okay, that's fine. So now, if we have any unknown, which means at times we can use any of the formulas that we have to first find another unknown, then we can plug it into the equation that we know. So at times I know people want to avoid this quadratic for whatever reason, but as long as you get to the final solution, unless if the question specifically says use the quadratic formula to do this, then you have no option. But otherwise, well done. 2 seconds is the time it will take this object to get to the point of impact to the ground. Okay, question 13. I'm not gonna guide you through this one. Let's see how you guys can independently solve it. The position of a particle moving along the x-axis is given by x is equal to 6.0 t squared minus 1.0 t cubed, where x is in meters and t in seconds. What is the position of the particle when it achieves its maximum speed in the positive x direction? Maximum speed, positive x direction. Ideas. Okay, let's discuss ideas. How do we deal with this question? It wants you to find position, so it wants you to find the x value, right? When the particle achieves its maximum speed. So you want to tell or to know what is the maximum speed, or when does it achieve maximum speed. When you find this maximum speed, you know the time, you plug in the time, you should get x. Now I'm already telling you. Why am I telling you this? So anyway, how do we do that? The important part is, how do we know when is the point of maximum speed? At least there's still a question for you there.
Sorry, sir.
Yes.
On that question, I think we will have to derive the equations that we are given.
Mm-hmm.
Then I think that is the way that we can we can find the speed to derive. Then we'll
Maximum, yes. Good.
Yes.
All right. So how do we derive? What do we do by how do we derive? That's very good.
Like,
we are in the right track.
I think it will be x of v is equal to, then we take that, since it's 6,0 t squared, then we'll take that 2 on the square, then times it by 6.
Good. Okay.
Then we'll get 12 t.
All right, I get it. So 2 times 6.0 t. Okay, yes.
Then we'll have that 3 times negative 1 comma 0, then it will become negative 3 t negative 3 squared.
Negative 3 times t squared, right?
Yes.
Yeah, so you're right. Negative 3, we take the 3, multiply it this side. So negative 3 times this one times t with the new power, which is t to the 2, right? Because the power increases by 1. Good. So what you have done here is give us an expression for the velocity of the particle at any given time t. So you do that by differentiating. This process is, you have just differentiated. So when you differentiate x with respect to time, you get dx over dt, and dx over dt is change in displacement with time, and this is a velocity. So this velocity is the what gives us the speed at any given time t. But then what should I do now? What should I do at maximum speed? Okay, what's next? What do we do after this?
Like now the thing is I'm lost a little bit because we are not given any time to substitute on that thing.
Good, yes. So it's all right. It's not a problem. So the thing is, we have a particle that is moving, and if the particle moves as the square or as a function of that, it means this particle, can you see that the velocity is not constant, right?
Yes.
The velocity is changing. So what does it tell you about this particle? This particle accelerates. When velocity changes, it means the particle accelerates, right?
Yes.
When we get to maximum speed, what does that tell you about acceleration?
Then the
Stops.
accelerate.
There's no acceleration. So let's do it again. So for us to see the acceleration, we differentiate again for the second time, right? We want to know
Yes.
when is that point where acceleration is 0. That's the point of maximum speed, or a point of no acceleration, no more change in speed. You get the point?
Yes, sir.
Good.
But
So
I know I declined it, no problem. We can continue.
you had what?
I declined it, sir.
Oh. Okay, it's all right. Let's continue. So now, if we have this as our v, we do again a differential on v. So which is going again d squared x over dt squared, which is like doing a d over dt of this dx dt. So this dx dt is that we're differentiating for the second time, the same x, right? So if we differentiate this expression now, this dx dt, because this is v, so this is basically like dv over dt, which is equal to our acceleration. Okay, so now let's differentiate. It means acceleration is therefore equal to, what do we do to the t here? The power is 1. The 1 multiplies the 2. It still remains as 2, so we remain with 12. And the new power of t is what?
It's cancelled.
It's 0. Yes, it's 1 minus 1, which is 0. So there's no more t.
Yes.
Otherwise, you can write t to the 0, but there's no need. T to the 0 is 1. Then minus, what do we do to the 2 here on the second term?
We'll times that square. That we'll say 2 times that negative 3. Then we'll be left with negative 6 t.
T to the 1. Okay.
Because when we minus that squared, when we minus that 2 minus 1, then we'll get t. We'll get 1.
Yeah. It remains as t to the 1. Very good. So now what did we say is our acceleration at this point where we have maximum? Maximum.
It's constant.
At maximum, not constant, but specify what value?
Sure.
We said acceleration, okay. We said velocity is constant. Velocity is maximum. Velocity is not changing at that point because it's at its maximum, at its peak, right? So if velocity is maximum, acceleration is what?
Then it's 0.
0. Good. So acceleration at maximum is equal to 0. So we now have an expression with acceleration equal to 0, and we know what t is where my acceleration will be 0. Do you see it?
Yes.
So now what is the value of t there?
Then
12 minus 60 is 0. That means t is equal to 2. Okay, someone got 2. Rashan, good. 2, so it means 60 equals to 12. So 12 over 6 gives t equals to 2 seconds. Our t is 2 seconds. Do we all agree t is 2 seconds? Yes, we should. We should agree. So if t is 2 seconds, then what does that mean about the displacement that we need to find? It means this displacement at the point where we get to maximum velocity, we have no acceleration, blah, 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 we'll have moved for 2 seconds. And having moved for 2 seconds, plugging in t equals to 2 into that expression gives us x. So what is x? What is the value of x? At t equals to 2, 16. Okay, so that's 6. So x at t equals to 2, x for t equals to 2 will be 6 times 4, 6 times 2 squared, minus 1 times 2 cubed, which is 4 times 6, 24, minus 8 equals to 16 meters. Wonderful. So when t equals to 2, the displacement x is 16 meters. X is 16 meters. Do we have 16 meters there? It seems like we do. And yeah, that should be proper. So we got the principle. Did we understand the principle? Did we understand what we did with this question? I hope you guys were able to follow. So the whole idea is you are given a parametric equation in terms of time. It shows that the displacement changes with time. But now the velocity of the particle is the differentiation of this x parameter or of the displacement, which gives us the velocity. And we find that the velocity is also a function of time, and it changes as well with time. When velocity changes, it means we have an acceleration. But the condition for maximum velocity requires that there is no acceleration, because if we're at a maximum, there's no change, right? So having differentiated velocity, the velocity term, we get the term for acceleration, which only has one t. And because we have that term, we knowing our acceleration should be 0 at that time, at that point in time, then we find what t is and plug it back into the equation. We know x is 16. That's the procedure. Are you happy?
sorry, sir. So if I may ask, what if they were asking us to get the maximum acceleration? We were going to derive once or twice, or we derive it until we arrive at that stage where the acceleration was 12 minus 6.
Okay, that's a good one. Maximum acceleration. So taking note, if t is 0, what is acceleration?
If t is 0, then I think it's 12.
And if t is non-zero, because remember your t cannot be negative, right?
Yes.
So which means for any other value of t, you're actually decreasing from 12. Your acceleration is going towards 0. And if t is very big, such that you're like, if t is 3, you have 18, you're subtracting 12 minus 18, you get minus a negative acceleration there.
Yeah.
So already your maximum is 12.
Okay.
You see, you get the point.
Yes, sir.
Your maximum acceleration is 12. So you might find that as you increase the value of t, you get to a point where the acceleration is great in the negative direction. Because like for a value of t equals to 4, you have a 6 minus 24, which is minus 12. So looking at the magnitude now, because the negative is just showing it's a deceleration or it's an acceleration in the opposite direction. So if it is to do with the magnitude, then that magnitude can be taken as just as a function of the absolute value of that acceleration without the negative. So initially, when you start, t is 12, that's the maximum you have, and that system might oscillate between 12 and I'm sure minus 12, depending on the motion here, depending on what this motion it does with respect to this x. Okay, so that's basically one way to look at it. So remember, your question can just say what is the magnitude. What is the magnitude? If it's magnitude, then which means those accelerations that are in the negative can still give you the magnitude of the acceleration, because the magnitude is that size, or is that which gives you the value of the acceleration, besides the negative being the direction. So if you get something greater than 12, then that would be the maximum acceleration then. But since t can increase up to any value, you can plug something like 60 there. You find now something like 10 there. You now have 12 minus 60. You are now looking at something like minus 48. So the magnitude is 48 there. It's great. So it can, that question will kind of like be vague, in the sense that you can't just have a single maximum. It can only be a maximum in a certain range. So a maximum for x between maybe 0 and 16 meters, that maximum is the 12. But when we go beyond, the maximum is now showing that the acceleration is in the opposite direction, but it can get to values greater in magnitude than 12. Are you answered?
Yes, I am.
Okay, good. All right, that's a good question. It means also it allows you to think like at least outside the context of the question, and also try and understand the different forms and types of motions, and what possible questions can change and be asked in under the same scenario. Okay, so our next question here is question 13. We're almost done. Actually, it's question 14, so we're almost done. A car travels counterclockwise. I have space there. So question 14. Around a flat circular circle of radius 0.25 kilometers at a constant speed of 20 meters per second. When the car is at point A, as shown in the figure, what is the acceleration of the car? And the figure is not even here. Wow. Okay. I'll have to figure out what that story is all about. So we have counterclockwise is like going this direction. Okay. Oh, nice circle. Then the radius is 0.25 kilometers, which is 250 meters, and constant speed of 20 meters per second. So maybe let's start there. If the speed is 25 meters per second, 20 meters per second, the speed is linear speed, so it's tangential to that path in the circle. So when the car is at point A, as shown in the figure, what is the car's acceleration? Now, I don't know where point A is, but I'll have to figure out what that question wanted us to find. So there is constant acceleration and blah, 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 everything there. So assuming point A is at the top of this circle. Yeah. Assuming point A is here. So now I'm just going to try and figure out what that question was all about. So if that is point A, then this is tangential, and it means this is 20 meters per second west, right, in terms of the velocity. But then the acceleration is, what will be the acceleration? How do we find the acceleration in this case? So for a body in circular motion, A is equal to v squared over r. So this is the acceleration for magnitude velocity squared. And this acceleration is towards the center. So in circular motion, I hope you have started on circular motion or you discussed this. But what it means is for the body to be able to move in a circle, it means there is an acceleration that changes its velocity. Let's say the new velocity is there and is downward. It means now it has changed its velocity from this direction when it was at A, and if this is now at point B, to point B through an acceleration that is directed like that. So it means this is the acceleration there. When it's there, the acceleration is there. When it's here, the acceleration is also there. Acceleration is always towards the center for a body to describe circular motion or to move in a circular path. We call this centripetal acceleration. Centripetal for center seeking. That's what centripetal means. Centripetal acceleration. I hope I got the spelling. But anyway, the magnitude is given by this v squared over r. And because we have a v of 20, this is 400 over 250 meters. Convert to r to meters, you get 1.6 meters per second squared. And the direction, if A is at the top of the circle, like in my case, the direction of A is towards of the acceleration of if A is the point at the top of the circle, the direction of the acceleration is south, right? And if our initial point is at B, the direction is east, but the magnitude is still the same. So it could be south, it could be east, depending on where A, B points are on that diagram, which we can't see. But anyway, that's the context. The diagram is just a circular path with those points A, B, like that. So now, the point A, since we don't know where it is, I'll assume it's where I chose. Otherwise, the answer should tell us. So since I chose that one, it should be south. But if it's at another point, then it will give us the magnitude with the... So it says west. So if it says west, then which means that point should be here. This is point A, where the acceleration is in that direction. Towards the center. Acceleration in the westerly direction. So that's why it says west, which is E. So that point A is actually to the right of the circle. That's basically the thing of the diagram. But at least the magnitude, you know the magnitude there. And the direction is now a matter of where point A is on the circle. Take note, always towards the center. Always towards the center. Okay, the last question. The last question for the day. The initial speed of a cannonball is 0.2 kilometers per second. If the ball is to strike a target that is at a horizontal distance of 3 kilometers from the cannon, what is the minimum time of flight for the ball? So this is now projector. This is now projectile motion. The ball is to strike a target that is a horizontal distance of 3 kilometers from the cannon. We want to find the minimum time of flight for the ball. Okay. Okay, so 20 kilometers per second is the launch velocity. Actually 0.2. 0.2. It's actually horizontal, right? That is at a horizontal distance of 3 kilometers. What is the minimum time of flight? Oh, doesn't tell us much. Doesn't say much. So assume theta could be 0, theta could be anything, but the ball is launched and it has to hit a target that is 3 kilometers away. 3 kilometers away. and the minimum time of flight. So the minimum time of flight of the ball would be what? So if it is to hit a target that is at B, which is a horizontal distance, that's 3 kilometers away, there's no way theta can be 0, because if theta is 0, it will be launched horizontally and start falling lower than the horizontal distance of the initial launch position. So it has to be higher at a certain angle and then come down. As it comes down at 3 kilometers, it should come back to the same level. So the question, once the minimum time of flight, how do we get that? How do we get that? Any ideas?
Sure, sir.
Mm-hmm.
But I'm not so sure. But so from A to B, it is the motion of a ball, right? Of a ball, right?
Mm-hmm.
So from point A, I think like on that maximum point of height, the time there when the ball is about to turn back to the ground, I think the time there will be 0.
At maximum height.
I like the velocity there, I think will be 0.
Yes, so the velocity in the y, or the vertical velocity, is actually 0. That's true. That's true.
Yeah, so from A, so we have the initial velocity, and on that Vy we have the final velocity.
Okay. So the initial velocity in the y, it will be, we can call it Vy initial.
Yeah.
Vy initial. And this is like Vy final for that part of the flight, right? And we agree that the time it takes to get to that maximum point is half the time of flight, right?
Yes.
Okay. So what is our Vy initial? Because remember, we have not been given theta. This question has not given us, has not done much justice in giving us all the required information, because we don't have theta. Ideally, Vy initial should be equal to the V given there, sine theta, right?
Yes.
And Vx initial, which means the component in this direction, the one that doesn't change usually in projectile, is equal to V cos theta. Okay.
I think I will need a little bit time to consider this. I didn't see that angle. Yeah. Okay.
Yeah, because this velocity, remember, this is motion in 2D, right? So because
Yes.
it's motion in 2D, there is motion in the vertical, which is described by a velocity Vy, and there's motion in the x, which is, or in the horizontal, given by the velocity or the component of the velocity Vx. So now Vx does not change with time because there's no acceleration component in the x direction, such that our displacement in the x from A to B, so we can say x from A to B is equal to V cos theta times that time of flight that we want to find, right? Whereas,
Sorry, sir.
yes.
So you think we then, like the distance that we have, it's for AB, right?
Yes, it's for AB.
Which is 3 kilometers.
Mm-hmm.
Then if we can cut this like from that displacement from A to B like into 2 equal halves, then I think we have the 1,5, right?
Yes.
Then if we are looking for an angle, then I think we can have that theta and 90 degrees, or because we'll cut it into 2 equal halves. Like
Okay.
let's leave it.
Yeah. So you're thinking like if the challenge is E angle. If you what can I do here? What can I get more colors? Okay. So the thing is, there's this angle here. Shit. Okay. So there's that angle there. Still, it's not changing. Where is it? Okay, good. So if you use this 90 degrees there, this angle is not the theta that we want. This is now a different angle there.
Yeah.
You see it. So the idea, you are close though. You are close because what we already have this XAB, which you have said, let's say, is 1,5 kilometers, right?
Yes.
Is this color visible to you?
Yes.
It's not damaging your eyes.
No.
Okay. So 1,5 kilometers is V cos theta. We don't know what cos theta is, but we know V, right?
Yes.
And we want to find T. So we've got two unknowns here, this cos theta and that T. Then what we also know is, from what you gave us, if we have Vf equals to 0, then we can say, which equation can we use there? V initial, V final is 0. So V minus U of T. V final equals to V initial plus 18 plus 80, right? But V final is 0. V initial is our Vy sine, Vy we said is V sine theta. So it's just Vy,
Yes.
which is Vy initial, which is V sine theta. Okay, so let me just write as Vy final and Vy initial. Then, so it's V sine theta plus minus 9.8 times T, right? Do you agree?
Yes.
Because this
Yes.
we're considering velocity to be positive going up.
Yes.
So the acceleration is negative. So that means in this case, we've got T equals to V sine theta. T equals to V sine theta over 9.8 or over G.
Yes.
So if we plug in for T here, we've got V cos theta. So we're plugging in, this is our equation 1. This is our equation 2. And so what are we doing? We're saying equation 1 into equation 2.
Equation 2.
We substitute for 1,500 meters equals to V cos theta multiplied by T, which is V cos theta. Did I do it right? V sine theta over that.
Why don't we substitute with the value of T or on this equation 2? Then it will be V cos theta into V sine theta divided over 9,8.
You know what? I wanted to divide these things. Let me not substitute it like this. I wanted them to divide. So let's keep it like this. So we're saying v cos theta t, then v sin theta. Oh, it's two unknowns. Okay. Will that eliminate? What will it eliminate if we remain with? Okay, I think it's fine. So 1500 equals to v cos theta times t, which is v sin theta, over 9.8. Because we have v, our v is 20, right?
Yes.
So 1500 equals to 20 times 20, which is 400, times cos theta sin theta, over 9.8. Okay, but 2 sin theta cos theta is, what is that identity? Of 2 sin theta cos theta, is there an identity for it?
Yeah, I think there is.
It should be sin 2 theta, right?
Yeah, sin to theta.
Sin 2x formula is exactly. Okay, so this means if we split this, we can take 1500 and multiply it by 9.8. It means multiply by 9.8 this side and by 9.8 that side, and we remove this on that side. Then we get this is equal to 200 times 2 sin theta cos theta, which is 200 times sin 2 theta. So if we divide again by 200, we've got 1500 times 9.8 over 200, which is 15 times 9.8 over 2. Still something doesn't sound right though. I don't know. Okay, 15 times 9.8 divided by 2. This is supposed to be a fraction. This is supposed to be a fraction. Meters, consistent units, 20 times t. Kilometers. P sin theta over 9.8. Oh, sorry. Sorry, guys. I've seen I just got excited here. So this is 0.2 kilometers, which makes it 200 kilometers per second, right? This V, take note of this
200
V,
meters.
200 meters per second, yes. So this is 200 squared, not 400. And that 200 squared is 40,000 instead of 400. Yeah, that's why it was becoming fun. So we have 40,000, and if we divide by 2, that's 2 times 20,000. So we've got 2 times 10 to the 3 there. 2 times 10 to the 3, is it 20,000, 10 to the 4? Over 2 times 10 to the 4, 20,000. So that we have this we did so that we've got 2 sin theta cos theta, if you remember. So once we have that, we can now divide 15 over 19.8 divided by 20,000. Because the sin theta should be a fraction. That's why I was worried. 1500, like that. So if we remove the zeros, we'll remain with 2 zeros there. So 15 times 19.8 times 9.8 divided by 2 times 10 to the 2, which is divided by 200. 0.735. So arcsine of that gives you 47 degrees. So arcsine 2 theta gives you 47 degrees, such that 2 theta is equal to 47.31, and then theta is half of that, 23.65. So that's the angle. So it means for your time of flight, then it would mean substituting theta there to find t, but remember this t applies for half the time of flight. So if we go back to the equation 1, and substitute 200 meters per second times sine, what is that, sine 23.65, divided by 9.8, that gives a time of 482 seconds, and this is just half the time of flight. So multiply that by 965. I don't know if all that we did is proper, not at all. Ha ha ha. So what will that time of flight be at angle 45? Okay. Any ideas? Any ideas about this question? I think finding theta this way will not is not helping us in any way. If this were horizontal motion, the simplest case to consider for horizontal motion is when the distance 3 kilometers is divided by the v cos theta, but still we don't have this v cos theta. Divide by 200. What do you get if you divide 3 kilometers by 200 meters per second?
15 seconds.
15 seconds. There's no 15 seconds there. Minimum.
But,
so does it say minimum? Let's see.
Yeah, it says minimum.
Then.
Then it'll be 16 seconds.
It will be the 15 is actually 15 exact.
Is it 15 exact? Oh.
Okay. So ideally what's happening with this question is this angle, if we are to project, because it says minimum time of flight, and so if let's say the body is not okay, I didn't want to go this route, but if the body is not under gravity, then it means if the body has got a velocity, if this launch velocity that we said is not given in terms of the angle is 200 meters per second launched horizontally without falling, then that is where we get the 15 meters per second. So that becomes the absolute minimum. But because there is gravity, it means we need to launch it at a certain angle, and that angle will give us at least an extra, what can I call it? Will give it an additional time above 16. So without finding that angle, then I'm sure you can eliminate D is already out, because with the horizontal displacement or with the horizontal velocity as the launch velocity, we get 15. So all these 16, 21, 24, and 19, 16 becomes the most ideal in terms of the minimum depending on gravity. Yeah.
So in this case, must we assume that the angle is 0 because of the minimum?
Yes, if we assume the angle is 0, then that's where we get the 15. So having got 15, it means taking out that assumption, it means whatever minimum angle that we can do should give us any other time slightly above 15. So that's why the minimum we see here being acceptable is 16. Otherwise, I don't have any plausible explanation for this in terms of the calculation that gets to this directly. I would
No, the question is crazy.
Sorry?
This question is crazy.
Yeah, it's quite crazy, but at least that line of thinking to start with the horizontal launch and get the minimum, but it means you have already assumed that gravity is not acting on that cannonball to pull it down below the horizontal that horizontal direction. But otherwise, yeah, that's that would be it. If there are any other questions, are there any questions? So if we don't have any further questions, let's meet again in the coming weeks. So if as you read, you come across some difficult or challenging questions, you can bring them on the platform. So each time we'll let you know when we will be online. Usually Lucian would come on Wednesdays, Arnold on Mondays. But if they are quite held up with some other commitments, then they'll let you know via email which times you'll be meeting. But otherwise, thank you for joining. Let's meet again in the coming week. All the best with your studies. Bye-bye.
Thank you, sir.
Goodbye.